Hi guys, today we're going to start Unit 3, which is covering systems of linear equations. Today we're going to talk about solving systems of linear equations on Chapter 3-1. Let's get started. So first of all, here's a couple of definitions that you would want to know about. A system is just talking about two or more equations with the same variables. To solve a system, you have to find the ordered pair that satisfied all of the equations. For today, we're only going to do two at a time. Systems of equations can be classified in number of solutions. It will be consistent if it has one solution, inconsistent if it has no solutions. Independent has one solution, and dependent has an infinite number of solutions. You'll see what happens when we get no solutions. That'll be like if I draw a graph and my lines are parallel. Because what we're mainly looking for is an ordered pair where they intersect. So if they're parallel, they'll never intersect. Another thing for dependent will be if it has an infinite number of solutions. Say we end up working a problem out and we get a line and then we get another line that actually has the exact same slope and the exact same y-intercept. It's the same line. That's when you get something that's dependent. So let's go ahead and solve this first example by graphing. So what we need to do is first get these two equations in slope-intercept form. I'm going to do that by simply rearranging. I'm going to take this first equation and I'm going to move the 2x by subtracting 2x on both sides. I'll be left with negative y equals negative 2x minus 1. Of course, we don't want negative y, so I'm going to divide both sides by negative 1. My slope would be 2, my y-intercept would be 1. So let's go ahead and graph. Rise over run means go up 2, right 1. And I like to go to both edges of the graph because remember what we're looking for. We're looking for the point where these two lines will intersect each other. So with that being said, I'm going to try to give myself as many points as possible so that I can find it. I'm going to do the next problem in green. So what I need to do is rewrite this one, rearrange it by moving the 3x. So I have y equals negative 3x minus 4. And with that being said, my slope is negative 3, my y-intercept is negative 4. 1, 2, 3, 4. So this would be going down 3, right 1. I'm going to go up and backwards. I really just need to find the place where they intersect, and it looks like I found it. But I'm just going to draw a couple more points. So I'm going to go ahead and connect these points here. But I noticed something pretty special is that right here at this coordinate, I'm sorry, my graph is just a little bit off, but right here at this coordinate, the two graphs intersect, and that coordinate is negative 1, negative 1. So the solution to this is negative 1, negative 1. If I were to plug these values in, the x value and the y value, then you would notice that it would be true for both of these equations. Go ahead and try this one on your own. Pause the video here and you'll see my solution in just a minute after you try it. How about it? Did you get the answer right? If you graph this properly, both of the graphs actually turned out to be the exact same thing. And when that happens, you get infinitely many solutions. All right, let's keep going. Example 2, in this one, we're going to solve by using elimination. Now, this is a different method from graphing, whereas in this method, you want two things to happen. You want to have some integers, or not necessarily integers. They can be any type of numbers, but you want a positive and negative value of the same number. So positive or negative value of the same number. If you have this, then that's going to make your equation a bit easier to solve. If you don't, then what you're going to have to do is multiply one or both of the equations. Multiply one or both equations by some number to force this to happen, to force a positive and negative value of the same number. All right, let me show you what I mean. In this set of equations here, I have a positive 3y and a positive 3y. But what I really want is a positive 3y and a negative 3y. So in order to make that happen, I'm going to multiply this top row by something. I'm going to multiply it by -1. And the reason why I'm doing this is to get that positive value and negative value of the same number. So I'm going to have negative 5x minus 3y equals positive 19. And then on the denominator, I'm just going to keep it as it was. 8x plus 3y equals negative 25. If you notice when I did that, what happened was these y's now became just what I wanted, a positive and a negative of the same number. I have a positive 3y on the bottom and a negative 3y on the top. This is why this is very handy for us and what we actually need. For elimination, what I'm going to do is combine the two equations together, so the green and the pink. So I have negative 5x and then positive 8x, so negative 5x plus 8x is 3x. And then watch what happens here. Negative 3y plus 3y cancels. You want that to happen. Equals 19 minus 25. It's negative 6. And finish solving. And I get x equals negative 2. So if this was just a regular equation, we'd be done. But the fact that this is a system of equations, we need an ordered pair to find our full solution. So we have the x value. If you have the x but not the y, just plug it in to get the opposite value. So I'm going to plug in x equals negative 2 into one of these equations. It doesn't necessarily matter which one, just pick the one that looks easier. I'm going to go with the top one. 5, and instead of x, I'm going to put negative 2. Because I'm replacing right here, I'm replacing x with negative 2 in order to figure out what y is. Let me see, so it was 5x. And yes, I could have chosen the other one. It just depends on what you find easier. And finish solving it. So add 10 on both sides. And then divide by 3. So my answer is the coordinate pair, negative 2, 3. Okay. For these next couple, I do want you to try it on your own and see if you can come up with the answer. Go ahead and pause the video here and see if you can do this one on your own. Alright, so the answer here was no solution. You can raise your hand and ask me to come around to help you if you didn't get that answer. In any case, try this next one here. Go ahead and pause the video and take a minute to try it out. Do you notice the difference between the answer you got on number 3 and the answer you got on this one? On example 3, when we worked it out, you got a false statement. Anytime you get a false statement, what happens is that's when you have parallel lines and you would never have a solution. On one like this is where I worked it out and they actually end up being the same line like in the graphing one I had you try on your own. So this one would be infinite solutions. Go ahead and try this next one. I am going to give you a little bit of hint to help you get started on this one. When I'm looking at this problem, I can't notice anything that I can multiply just one of the equations by. So sometimes you do have to multiply both equations by a number in order to create that positive and negative of the same value. What I'm going to suggest, and this is just a suggestion, you don't have to do it, multiply the first equation by -3 and multiply the second equation by +5, because that would create a -15 and a +15. That would be my suggestion to you. You can find another way if you like. Go ahead and pause the video here and try out example 5. This will be the last example. The answer was -6, 0. Did you get it? I hope you did. If you didn't, just make sure to ask some questions and I'll be happy to come around and help you. In any case, you're going to work on practicing more elimination and graphing, and go ahead and watch the next video for tomorrow's notes. Bye!